Thanks everyone for joining this webinar. I'm Tony Rothbilly. I'm Professor of Energy Systems at Durham University, and I lead the EPSRC network for hydrogen fuel transportation, which is a webinar is part of a series that we are organizing to look at different aspects of hydrogen research in the transport sector. So this week we are welcoming two speakers on the subject of hydrogen production and supply for transport, and they will be giving their own thoughts from an academic and a policy perspective. Thalia Skoufa, she's a practice manager at the Energy Systems Catapult, looking at projects at decarbonisation of the transport sector, energy supply for electric and hydrogen vehicles, and infrastructure requirements to support the uptake of ultra low emission vehicles. She is providing technical support to the EV Energy Taskforce steering group and has been involved in the Innovate UK funded project Vehicle to Grid Britain. And that is assessing the viability of vehicle to grid across the UK, and is also, in terms of her background, she's a chemical engineer and has a master's in renewable energy engineering. So over to you, Thalia.
Thank you very much. Thank you for the introduction. I will give a quick overview first of what the Catapult is. So the Energy Systems Catapult is part of the Catapult network set up by Innovate UK, and we're an independent non-for-profit organization, and our remit is to look at take a whole system view and understand where innovation is needed and how we can unlock new markets to support clean growth and innovation. We do that by various ways. We support small companies directly to help them bring their products to market, but we also do quite a lot of work with government and other organizations, advising them on different pathways, specifically to reduce emissions and meet our net zero emission targets. And as you can see, we've got quite a range of capabilities that we bring them together to address specific challenges. So we do varying things from modeling to policy and regulations, to looking at digital technologies that will enable innovation as well. But we also have what we call a living lab. So we've got a number of homes connected to our network, and we can trial and test new products and services with consumers to understand what are the requirements and how would they be responding to all these new products that are coming to market. And because we take a system view, we try to link everything from generation to production of energy, but also understand the different demand sectors and how these might be evolving over the years. So where we see demand changing and the energy mix changing, but also how do consumer requirements change and how people use services and products. So we follow a similar approach for hydrogen, and we've been looking for hydrogen across the energy system. As Martin was describing earlier, there are different ways to produce hydrogen, and there are different ways that we store hydrogen depending on where, if it's going, depending on the scale, I guess, and depending on the duration, depending on the location as well. But also we've got a mix of different solutions for distributing hydrogen as well. And that would be dependent on a number of factors, on the scale that is needed, on the particular location, on the demand mixtures. So anything from having hydrogen networks similar to gas networks of today, but also through transport-based distribution systems as well. But also different ways where hydrogen can be used. It's not just transport. Martin also pointed out the fact that transport might be a small part of that. There's other things like reducing emissions from our heating demands. So hydrogen could play a role in terms of hydrogen fired boilers, but also using small combined heat and power modular systems at homes. Industry is another major sector that hydrogen will play a role, especially in sectors that would require high grade of heating for processing, but also potentially for producing electricity as well. So quite range of options, and all these can be combined in different ways, and it's not a one solution that would fit all. We might see a mix of production technologies and a mix of different types of storage needed to serve the different end use applications. So I guess the problem that we're trying to understand gets even more complex when we factor in all these different options and choices that we've got on the production side as well. So we've got different methods and ways, and Martin described them quite well on how to produce hydrogen. But again, that would be dependent on a number of factors, but also dependent on what technologies or a development of other technologies. For example, we talked about carbon capture and storage, but the development of the technology and the scale up could also have an effect on what methods are used for producing hydrogen. So, and also, as I said before, it's the interactions between all these different ways of producing, storing, distributing, and using hydrogen that they might be complementary. So we might see that, for example, in areas where there's lots of high industrial activities, for example, so hydrogen has a role to play. That's hydrogen used for transport, or hydrogen used for any district heating systems, for example, could be a solution. So there might be complementary usage that could encourage early hydrogen utilization, but also they might be competing. So we might see that across these different solutions and generation methods, there might be areas where actually producing hydrogen from one source might be competing with something else. And also taking a step back and looking at it from a system perspective. So what would be the methods and the ways that we're generating our electricity, and how can we optimize in terms of an overall system balance, supply, and stability as well. And as I said, for every case of using hydrogen, there might be an alternative that might offer specific opportunities as well, or challenges. So that is a little bit to illustrate the complexity of the problem, and that there's definitely not one solution, and we can't have a single view of the energy system in the future. There's so many factors that are affecting our choices and our options, and there might be infinite number of different pathways that we might be looking at, and they're all interlinked and dependent. We did a piece of work last year and a half ago now, that we tried to understand what's the impact on the energy system, and what might be the different pathways for us to achieve our net zero emission targets by 2050, and how would the energy system change. Hydrogen is one of these sectors that there's quite a lot of change, and there will be quite a lot of demand for increasing the scale of being key in reducing emissions across the different sectors. So as with electricity, that we're going from about 300 terawatt hours today to having a demand of up to 900 terawatt hours, hydrogen could be scaled up to and there could be a demand of about 300 terawatt hours per year by 2050. So quite a big jump and a big increase. And we take a scenario approach, but in every single scenario that we've modeled and looked and analyzed, hydrogen plays a key role, and hydrogen is one of these energy sectors that could take us to meeting our net zero targets. And in taking in a little bit more, looking at it in a little bit more detail, we've got here two kind of like distinctive scenarios. On the right left-hand side, we've got what we call clockwork, where it's based on central policy decisions and central governments making key decisions and promoting and supporting the development of technologies. So we see, for example, high use of generating hydrogen through fossil fuels combined with carbon capture and storage. We make the assumption there that CCS technologies are more advanced. That's because we've got that early backing from central decision making. We can achieve higher capture rates. And then on the right-hand side, with our patchwork scenario, we see CCS not being deployed as much, but we see much higher need for electrolysis. So this is an indicative example just to show that whatever pathway we choose, there's probably going to be different mixes of technologies utilized in the system, but but hydrogen demand is still there. It varies, but hydrogen demand is still there across all energy sectors. Sorry, across all demand sectors, from industrial activities, transport, but also heating, electricity generation, and shipping as well. We've separated shipping here because we think it's going to be one of these sectors that would have quite a high percentage of the demand. And you can see the progression is this in the scale. So as we move from 2030s out to 2050, there's a big jump and big push in hydrogen usage, simply because the system would need to meet specific emission constraints. And I guess a summary of our findings. So in terms of demand, I think we've talked about that a little bit earlier as well, that it's those sectors that they're harder to decarbonize and that they are harder to be electrified as well. So hydrogen would play a key role in areas like heavy goods vehicles, industry, and to some extent power generation as well, to provide flexibility in the system. There's uncertainties on specific technologies, uncertainty around capture rates and scale up of carbon capture and storage, but also scale up of electrolysis as well. In terms of providing heating loads to homes, there's quite a lot of activity in electrification, but again, we need to look and understand the local system, and we need to look and understand how, if hydrogen could be a cost-effective way of decarbonizing that specific demand area. But also things like large-scale storage, for example, and how can we utilize that to be able to have a steady supply stream of hydrogen throughout the different seasons and the years. It's clear, I think, and I'm probably not saying anything that you haven't heard before, that there's quite a lot of challenges and innovation, but we've seen in the last few years quite a lot happening in this space. So the question for us is not that if hydrogen will play a role. The question is how can we make that happen now, and how can we make sure that innovation is in the right areas, and that we progress with large-scale demonstrations, improving the different use cases that we've seen. And that's just a few examples of reports and work we've done that we've looked into hydrogen specifically ranging across the different sectors from production to end use. And I guess there's, as I said before, a few key messages. The main ones is that demonstrations are needed, especially around the transport sector, and understanding how the whole supply chain can be brought into place for scale up and mass uptake. We found that salt cavern storage is one of the most cost-effective ways of storing large quantities of hydrogen, and we need to understand now how that can be utilized. And I think there was also a question in the chat earlier: how do we determine what's the best approach in terms of distribution? And then that is clearly influenced by the volume and the ends use. So it's not, again, the same message. It's not a solution that would fit all. It's completely dependent on the use case and the local area demand as well. I'm going to skip through that just to point out that there's quite a lot of activity happening recently on hydrogen, and there's been more published recently as well. But in the 10-point plan, we've seen quite a lot of key hydrogen-specific messages, which is quite encouraging. I'm going to give a specific example and just look into one transport sector in a little bit more detail and talk about some work we've done a couple of years ago now. So we've seen obviously that for cars and smaller vans, that electrification is the preferred energy vector, and that there's quite a lot of activity in the area. But when we're talking about larger vehicles with different duty cycles and operation types, then the preferred route to decarbonize them is not as clear. And we can see that, and it's quite obvious that even though there's way more cars and vans in the UK, there's quite a lot of emissions related to heavy goods vehicles, as you can see here, and that they have higher loads, but also their distinctive operation cycles make them more difficult to electrify. We've worked with a range of organizations and partnered with the Advanced Propulsion Centre to understand the different pathways for reducing emissions from the freight sector. And what was quite clear from the beginning was that we don't see a clear decision point, and we don't see that a particular energy vector could be a solution that would fit all. We've seen, and we went back and started talking again to freight operators and OEMs, and looked to understand the specific operational profiles and understanding a little bit what are the requirements from specific freight sectors as well. We wanted to look at what are the benefits and drawbacks from using each energy vector for the specific operation type, and what the impact would be on the decision makers. So, what would be the impact on the specific fleet manager, and how would their decision process can capture decision making on the energy vector as well. So we collected quite a lot of data, and we looked at the vehicles themselves, the different configurations that could be available and could be applicable to the different operational types, but also how these changed depending on the energy vector used. We looked at other factors like commodity prices, our expectation on hydrogen generation, and in carbon intensity as well, and look to understand what would be the vehicle economics, but also what would be the fleet implications based on that. that exercise gave us the opportunity to understand the wider challenges as well, and the fact that data is not widely available, and that there's a lack of open data, and in terms of not only the vehicle supply, but also in terms of infrastructure options as well, and also looking to understand the different business models that might be needed, but also policy decision, and where and how can we use policy to help us decarbonize the heavy goods vehicle sector as well. So in terms of hydrogen powertrains, and in terms of using hydrogen as an energy vector, costs would be a main driver, and being able to have improved performance. And I guess we've seen that there's quite a lot of activity in that area to improve performance and reduce costs. But we would need to have that steady supply of hydrogen for transport, and we would need to make sure that there's kind of like a support for developing that system of either this hydrogen distribution network, but also kind of like central infrastructure, like refueling stations, in terms of standardization of processes, but also identify these areas and cases where local electrolysis could be a solution, especially earlier on. So other things that we think are critical is purification methods, and making sure that we get transport grade hydrogen where needed, but also to have that kind of like policy measures to support innovation and not restrict innovation. So I'm going to leave it at that, and yeah, happy to take questions.
Thanks, Thalia.